Hello, my name is Rasmus and this will be my handling code 3 for the image processing course. It will be 15 filters of point processing, and I'm also going to do a second part for the handling code 4 handling code 4, which will be neighborhood processing. And this will be the A cos, will be inverse cosine of each pixel in the video feed. So first we got a nested for loop with also a for loop for each color, because we're just going to do the same operation for each color. Start by we have a lot of double here, which we're going to use to do the calculations, and we start by giving the pixels value to the first value, the first double, and then we're going to scale it down, take the ACOS of that pixel and scale it up again. And then we do some calculation here to make sure that it won't go out of the range. And the last part, we put the value into the video feed. Yes, and it's going to look like this. Just has to start my camera. But you can already see the effect on the picture on the two pictures here. Is it gonna start? Camera? Maybe, maybe not. There you see. It looks kind of like the invert, so that's really the effect of it. And I look funny. Right, next picture, next point processing filter, and that will be the alpha blend. It's a filter which will take a picture and then my video feed and put them upon each other, so you have half of one of them and half of the other. And yeah, here you can see the algorithm, which I make a double variable that's called p for percent, and I set it at 60% right now, and I start multiplying for the first pixel, and then I say 1 minus the percent to get the percentage I want from the next picture, and I load off a picture up here, and then we will see what happened. And you can already see here on the video feed I had to make the feed bigger so it will fit the picture I found, and you see yes, I am behind the picture. And if I change the percentage, one of the picture will be more visible than the other. Right, next filter, we don't got all night, and that will be the binary. And the binary I've done here is from grayscale to binary. So actually it's kind of two, but I will also go through the grayscale. So I take a threshold and the intensity, which is about half, not completely, but about half. And then if they are above this threshold, I will set them to white, and else they will be black. And the effect will be like this. As you can see already here on the picture, the white is white, and well, I guess it's kind of black in dark in here, so you see just part of the light part will blow up. Right, next picture, and next filter. It's done binary. Then we will take the exponential of each pixel, and I will open in a minute. And we just use standard here. A nested for loop, and yeah, first I make a variable called k, and that will be the variable that can be changed to make different intensity of the exponential filter. Then I take the pixel out and also made it into grayscale just for convenience. Then I make my double c, which is a constant that can be changed. And then I do my calculation here, and actually I made it wait a minute, no, that is just to check if they go on beyond the boundary of the picture, beyond the pixel value. Here, down here I make the calculation. That is algorithm found in the course book, and here you can see what will happen. Maybe a bit high on the, but yeah, you can see the effect. It's a bit high, but it's because it's a dark room, I think. I can just try to put down the intensity here, maybe down here, and see what will happen. And just take a minute because it have to calculate. Oh yeah, that's the wrong way apparently. Well, yeah, you can see this start out and then it will take over. We say 9 here. That looks better, more visible. Yeah, then you can see. Actually, still get lighter. Yeah, but yeah, that's the effect that this has. And then we're gonna do the gamma correction. Right. Have the test tab here, and then we do the calculation for the gamma correction. That is first, this will scale it down. I've done it this way because somehow it didn't work when I divided with the 255, and then I do the the exponential to get the gamma correction, and then I scale it back up. I can make that bigger to get another effect. You can see here it is all darker. So that's kind of the effect of the gamma. You see the two video, the gamma correction feed is darker. Right, next. Oh, grayscale. That is very easy. This grayscale I have made where each pixel have different weights, so we can put some more weight on one of the pixel, and then you can see here we first take all of the intensities and then plus them together with different weights here. Here you can see my blue has more weight than the green and the red, and then I multiply them together. Plus add them together, and yeah, and they have to give 1, so we can change the weight. If we want to have 50 weight here, we have to take 3 down on blue. But yeah, it will look like this. I think it's gonna open, and you see we got a grayscale. Right, onwards we go. Onwards, hue shift. That is simply changing so the blue gets the red intensity and the green gets the blue, and so on. And that's simply just taking and shifting them around. You can see here I get the green to the red, and the blue to the green, and the red to the blue. Because of that, we'll see, especially in my face, because there is some red pigment, it will be more red. More blue, sorry. You see already here our blue lights get green. Oh yeah, and I am completely blue and my eyes are green. And yeah, you can see the effect. I look like a Smurf. Next, inverted video, it will look a lot like the ACOS video. So right here, and to get the inverse, we take and subtract the total pixel value from the pixel. and we just use a single for loop here with the total pixel integer, and then so go through all the pixels. Yeah, it will look like this, and you can see here it looks a lot like the ACOS, just but different. It's kind of the same, it gets the same feel, but not the same. Yeah. Next. Oh, log mapping. It's kind of like the exponential mapping, but it has another effect. And you have to do, of course, with the logarithm instead of exponential. Again, I make it to the grayscale because it seems to work best that way. I make the threshold to make sure it doesn't exceed, and then I do the calculation down here, and make the variable here based on max pixel value. And this is the effect, and you can see it looks kind of the same. It's just more gray than bright, and it actually works better with dark pictures, so perfect for my room. Normalized RGB. Here we go. And next one is gonna be pink color detection. I made it for skin detection, an algorithm I found for that. Right, first I found out total pixel value for each go through each pixel, and then I do the calculation here, which is taking the pixel value divided by the total pixel and multiply it by total pixel. Scaling up, down, scaling up, and we will get it's total different picture, which got more focus on the intensity. So yeah, you can see here on the screen it's very blue, so it will be very blue, and well, it's reflection on my black jacket. It will make more blue light, so that will be more bluish, but it's most dark, so that's why you can see it flimmering about there. Right, onwards. Pink color detection. I'm just gonna close this one down and open the next. Slash skin. And next will be salt and pepper, and then we're almost done for this first video. And here we can see the algorithm for finding a skin color. It's just a lot, and then we take and make it into a binary, so we can see where the skin color is. And it also depends a lot of the illumination, so it might not work this good in my illumination inside my room here. But let's see. See, at first it doesn't get anything for this picture because we don't got any skin color here. And yeah, you can. It works maybe a bit. It gets some of the values also behind, but you can see my face and my hands, kinda. You can see where it gets more dark, it will not detect, but if the light is good, it will detect me. Salt and pepper noise. Also a bit fun. Right. We first take, now we're gonna take the 200. If I change this number, it will have more or less noise. I would show it, but we take a random number and say if it is 0, that number, we will make it white, and if it's 1, we will make it black. Or else we're just gonna give it a normal value. So if you say 100 here, we will not have that much. You can see it's not that much. But if we set it down to 3, which we have to have 3 different values, else it's just gonna be black and white, we'll get a lot different picture, where it's almost just noise, salt and pepper noise back. Right, you can see it's much more profound, and lots more noise. It's just how big chance there is for detecting black and white. And now the sepia, it's kind of color grading, I guess, with some different algorithm for each color. See, we get some red and some green and some blue for each, and it's different for each. Actually, I had some problem with this because it broke, so I have to find a way to fix that, and that was making sure that all of this went up to 1 and all of this went up to 1. It might not be right now, but else it looked weird, and I try to do this instead, and it gives kinda still a sepia look, you can see. And this, it's more that brownish feel, and yeah, it's maybe looks a bit like the black and white, but it kinda works. Next one is brightness, and that is a very simple one, as I'm gonna explain in just a minute. Right, here we go, and we used a normal for loop here again, and just here I made some changes and just made a variable for the brightness, and here we also make sure that we don't exceed it, so it won't fuck up. And then we take and plus it, and we make this to make sure that it will stay on 250. That's just my computer complaining, or my security system. And you can see here we have about 100 pixel more bright here, and you can see, hey, more white and bright picture. It's lovely. And the last one will be the contrast. That will be scaling down and scaling up and multiplying based on a value. So first here I will take all the intensity and give them their own value. Then I will define a variable for the contrast, and then we just start with pixel R here. And we start by lowering the R value down, and then taking the brightness, I think it is, multiplying by the contrast, and then taking it up again to the normal pixel value. Then I'm just gonna check if it's over or so we say if it's too low it will be black, and too high it will be white. And else, if nothing of these is true, we're just gonna give it the pixel value, and we do that for all the different colors. And you can see here the contrast will go up, and I will have a more dark based on, I think, 50% or 150 or something. That's how it's look. You can see the difference for the two pictures. Yeah, and that was my first 50 filters with point processing only. Thank you and goodbye.